On this problem, we have you work in a chemistry stockroom and your instructor asks you to prepare 4 liters of 15% hydrochloric acid, or HCl. The supply room has a bottle of 12% HCl and another of 20% HCl. How much of each should you mix so that your instructor has the required solution? Now, normally you'd probably just take the 20% HCl and use distilled water to distill it to get it down to 15%, but whatever, we're using the 12% HCl and mixing them together. This is definitely a mixture problem. Again, we're literally mixing things together, and our rates here, you can see the rates are actually written as percents. And these percents, they can be a little tricky when you first see them. Concentration, or your percentage here, because this is going to be a percentage of your HCl, your pure HCl, divided by a percentage of total volume. So if I was to multiply these together, I would take your concentration times your total volume, which is going to be in liters, and it'll give me a pure HCl in liters. Alright, so I'm going to do like this. I'm going to say this is I'm mixing 12% to the 20%, and my total here, the overall, the mixture that I'm going to get here is going to be 15%. Now I want to write these as decimals. I don't want to write them as percents. You'll notice I'm writing them as 0.12, 0.2, and 0.15. I know I want to get 4 liters of this 15%, so this is the total volume of the 15% HCl. So I'll write a 4 there, and since I have 2 of the 3 down here, I'll go ahead and multiply these together. This will give me 0.6 liters of pure HCl there. Alright, looks like those are all the numbers that I have that I can fill in, so I'm going to put in some variables. I'm going to put x and y for the total volume as opposed to the pure HCl, again because this way I can multiply these things together. The pure HCl for this 12% is going to be 0.12x, and pure HCl for this 20% is going to be 0.2y. My equations are here and here. So I get x plus y equals 4, and 0.12x plus 0.2y equals 0.6. Those are my 2 equations. This is the same thing as the previous examples, except you can see the numbers have some decimals in them. I could actually clear those decimals up. If I multiply through by 10, I could move my decimal place over 1 place on each of these. I think I'll actually do that. Let's multiply the second equation by 10. That's going to give me 1.2x plus 2y equals 6. So I moved the decimal place over 1 place on each of these. You can see it became 1.2. That's plus 2y equals 6. So I almost got rid of the decimals. Really, it's this number right here I was wanting to make into an integer, so that this other equation, if I multiply this other equation by -2, then when I do that, this 1y will become a -2y. But I have to, of course, multiply through the entire equation by -2. So when I do that, I get -2x plus -2y equals -8. Alright, so I add these 2 equations together. My y's cancel out. This, you might want to be careful. If you do the subtraction there, 1.2 minus 2 is -0.8. So -0.8x equals -2. Don't let the negatives really throw you off, though, because it's just an equation. You can still solve it. Divide both sides by -0.8. -2 divided by -0.8 is going to be a positive, so I'm just going to do 2 divided by 0.8 to give me 2.5. Alright, x represented the number of liters of 12% concentration. So let's find y. That was 2.5, right? Yeah, 2.5. I know x plus y equals 4, and x was 2.5. So when I subtract 2.5 from both sides, I get y equals 1.5. So that means I need 2.5 liters of the 12% acid and and 1.5 liters of the 20% acid. Before I give my final answer, I want to make sure everything works out here. 2.5 plus 1.5. That gives me a total of 4 liters of this mixture. And also 2.5 times 0.12 plus 1.5 times 0.2. I'm just running that second equation. This equation right here gives me 0.6, and that is exactly what I expected. Gives me 0.6, that 0.6 right here, or right here, however you want to look at that. So that is my final answer for this question.